It appears as though the black hole is forming, gaining mass and growing over time. But what does all of this have to do with our universe? If we were to account for all the different types of matter and radiation we can measure in the observable universe, we'd need to include the following. Normal matter made of protons, neutrons, and electrons. Neutrinos, which are elusive particles that interact rarely with normal matter. Dark matter is a mysterious substance that makes up most of the universe's mass but remains undetectable. Photons are the particles of light that carry energy from every electromagnetic event in cosmic history. Gravitational waves are generated whenever a mass moves and accelerates through the curved fabric of space-time. Our instruments can detect objects up to about 46 billion light-years away in every direction. By adding up all the energy from these different forms of matter and radiation throughout the entire observable universe, we can determine the universe's equivalent mass using Einstein's famous equation E equals mc squared. You might wonder what would happen if the entire universe was squeezed into a single point. The answer is the same as if you condensed a large amount of mass or energy into a tiny point, it would create a black hole. In the movie Interstellar, the main character, Cooper, escapes from a black hole in time to see his daughter Murph in her final days. Some have argued that the movie is so scientific that it should be taught in schools. In reality, many scientists believe that anything sent into a black hole would probably be destroyed. But a new study suggests that this might not be the case after all. When it comes to our understanding of the universe, the 20th century was full of surprises. A little over 100 years ago, we thought the Milky Way galaxy was home to everything we could see in the sky. We thought the universe was static, unchanging, and possibly eternal, governed by Newton's law of universal gravitation. Well, all of that changed dramatically in the span of a few short years. Einstein's general relativity replaced Newton's theory of gravity, explaining the connection between matter, energy, and the structure of space-time. According to his equations, the universe couldn't be static, but had to change over time, a concept confirmed by the discovery of the expanding universe. His theory also predicted the existence of black holes, which were later observed, detected, and even directly imaged. All of these discoveries presented a wild and speculative idea. What if our universe originated from a black hole? Could it be possible that our universe was born from a black hole that formed in a larger parent universe? And is it possible that new universes are born every time a new black hole is created? Let's find out. Let's start with the Big Bang. Some scientists proposed that before the existence of humans' Earth, the ignition of the sun or the emergence of galaxies, and even before there was light, there was an event known as the Big Bang. This event took place approximately 13.8 billion years ago, but what about what came before that? According to many physicists, there may not have been a before in the traditional sense. They argue that time itself began with the Big Bang, and thinking about anything earlier isn't part of scientific inquiry. Understanding what reality was like before the Big Bang, what it consisted of, or why it led to the creation of our universe is likely beyond our grasp and human comprehension. However, a few unconventional scientists have a different perspective. They suggest that just before the Big Bang, all the mass and energy of the early universe were compressed into an incredibly dense but finite point. Let's call this point the seed of a new universe. This seed is believed to have been incredibly tiny, possibly trillions of times smaller than any particle we've ever observed. Surprisingly, this tiny particle could trigger the creation of every other particle, along with galaxies, solar systems, planets, and even living beings. So how did this seed come into existence? One idea discussed for several years, particularly by Nikodem Pawlowski from the University of New Haven, is that the seed of our universe was formed in the most extreme environment in nature, inside a black hole. The idea is that the seed of a universe is like the seed of a plant, a core of essential material, black holes densely packed within a protective shell. This closely resembles what's formed inside a black hole. Black holes are the remnants of massive stars. When such a star exhausts its fuel, its core collapses. Gravity becomes incredibly powerful, creating temperatures of up to 100 billion degrees. Atoms break apart, and electrons are torn apart into smaller pieces. By this stage, the star has become a black hole with such strong gravity that not even light can escape. It took scientists 20 years to find an answer. They proposed that the information inside a black hole is related to its surface area in 2 dimensions, not its volume in 3 dimensions. This idea can be understood through quantum gravity, which suggests that the 3-dimensional space can be reconstructed from a 2-dimensional world without gravity, similar to a hologram. Soon after string theory, one of the most explored theories in quantum gravity, was also found to have holographic properties. Using holography, we can describe the evaporation of the black hole in the 2-dimensional world without gravity, for which the usual rules of quantum mechanics apply. This process is deterministic with small imperfections in the radiation encoding the history of the black hole. So holography tells us that information is not lost in black holes, but tracking down the flaw in Hawking's original arguments has been surprisingly hard. One of the defining features of a black hole is the existence of an event horizon, which is a boundary that tells a very different story for an object outside of it versus one inside of it. Outside of a black hole's event horizon, any object will experience its gravitational effects as the space will be curved by the black hole's present, but it can still escape if it moves fast enough or accelerates quickly enough in the proper direction. It won't necessarily fall into the black hole, but could break free of its gravitational influence. When an object passes through the event horizon of a black hole, it's destined to be pulled into the black hole's center. Inside a black hole, the curvature of space-time is incredibly intense, causing an object to reach the singularity within a very short time. After crossing the event horizon, this process also increases the mass of the black hole for an observer outside the event horizon. What are your thoughts about this theory? Tell us in the comments. Like and share our video with the like-minded people. And subscribe to our channel for more similar videos. See you in the next amazing video.